Hi, everyone. Just wanted to take a minute to talk a little bit about the area of similar figures. So, if you recall, a similar figure, in general, we're dealing with polygons, but they are figures that are going to be the same shape, but not necessarily the same size, right? So, the sides are going to be in the same proportion. So, all sides would be in, let's say, a ratio of 1 to 2, 1 to 4, 3 to 2, whatever the case, all sides are going to fit into that proportion. And if you also recall, that meant when we kind of started finding the perimeter, that the perimeters followed that same pattern. So if, the left shape to the right shape was 1 to 2, the perimeter of the left to the right was going to end up being 1 to 2. However, when you start getting into something like area, if you kind of start thinking about it, right? Let's say we start with this as 1 and this is, 2. As you can kind of tell, when you're starting to deal with area, you have multiplying. So it doesn't necessarily make sense to think about them being in the same ratio because when you start multiplying, right, that factor of 2 is being multiplied twice. So really it's being squared. So how does that all shake together? Well, if you have two similar polygons, the ratio of their areas is equal to the square of the ratios of their corresponding side lengths, right? So if we have our corresponding sides here, this was 1 to 2, the area, not volume, we're not there yet. The area would be not 1 to 2, but 1 to 4 because you're squaring, right? So if it was like 3 to 2, the area would be 9 to 4. All right. So that just helps you kind of set up the proportions so that you can easily solve. Okay. So for example, and we'll kind of do both ways on this one. Um, in this situation, right, we're given 11 to 44. Okay. So if we're given 11 to 44, well, we know the ratio of the sides, 11 over 44, right? That's 1/4. So you can almost think of it as this is 1/4 the size of this one. So now that doesn't necessarily give us the area, though. We know this one's area is 20. However, if we think about the ratio, it's not. This is not 1/4 of this one's area. It's 1/16 because we have to square this. So here's how we'll set this up: 1/4 squared is equal to 20 over, and I don't know, we'll call it x, the area, whatever variable you want to call it. So that's 1 over 16 is equal to 20 over x. Cross multiply, x equals 320 meters squared. I gotta make sure I have the unit right. So if you look at it, this one should have an area of 320 compared to this one's 20. And if you do that out, it will have the correct ratio of 1 to 16. Now, similarly, if you're given the ratio of if you're given the two areas, you can find the ratio. So let's take a look. 4590 over 510. Well, let's see. That appears to be 9. Looks to be about 9 over 1. Okay, so that'd be 9 over 1. Now, that is kind of the ratio squared, right? So the ratio that we're looking for when we're trying to find the sides is not 9 over 1. It's the square root of that. So it'd be 3 over 1 has to be equal to, and we put that one on the top. So let's keep this one on the top. So 21 over x, 3x is equal to 21. Ooh. So x is equal to 7. And what's my unit? Meters. All right. So that's how you can kind of set it up going the other way. So when you're given the sides, you would square the ratio. If you're given the areas and you have to find a side, you can take the square root of the ratio and then set up the proportion.